Okay, you're ready.
Okay. Hi, everybody. My name is Glenn Johnson. I'm the design and prototype mentor, and we have put together a terrific selection of projects for this year. I'm very excited that not only are we doing the International Space Station, but we're also looking towards our missions to the moon, which include Gateway and Artemis. With that, let's take a look at some of our pages here. So the very first things are just for some background information. So also there's more information on our website besides these links here. But the idea is space is not an easy subject to just start working in. You have to give yourself some background. So please take a little bit of time to watch some videos and to do some reading to figure out what the environment is that you're going to be designing for. Okay. Here's a couple more places to help out. All right, there are more websites. So make sure you go into understanding what the environment is that we're working in. So on the space station and the gateway will be in zero gravity. Whereas once we get onto the moon, we're going to have 1/6 gravity, and that can be a little bit difficult to work in as well, just because it's going to behave different. So give yourself some time to study up and understand where you're going to be building for. So the very first of our projects is the crew quarters exhaust diverter. And so here you see a picture of 4 astronauts that are coming out of their sleeping quarters. They're about the size of a refrigerator, kind of the inside of a refrigerator, and they have a place for their sleeping bags and personal items. But since there's no gravity, you don't have to be on the floor. You can be on the wall and even on the ceiling to be able to sleep. And so the difficulty that our crew members are running into is that air gets pulled in to the crew quarters and blows across their face, and then they have to pull the air out and it blows out, and you can see here that all 4 of them exhaust in the same direction. Well, the airflow through this module kind of blows that air almost right back into the place where the air gets sucked into. And that means that carbon dioxide and the heat from each one of these crew quarters gets blown right back into the next crew member's sleeping quarters. And so it would be nice if we could increase that air path so that there's more mixing before it gets dumped back into the crew quarters. And so here we're not looking for some kind of a fan or some kind of a extravagant device. We're looking for a very simple device to just push the air against the wall and make it take a longer pathway before it might get pulled back into into one of the other crew quarters. Okay. And notice at the bottom of this page here says, for more information, you can go to this other you can go to another site on our webpage, and it'll give you more detailed information about what we're looking for. Okay. This is not intended to be a big device. This is a fairly simple project. However, it has a very high probability of flying, just because this is something that the crew would really like. They've been talking about this as a difficulty for the past couple of years, and nobody's done anything about it. So I think this is a good opportunity for our students to make a difference. This next one I think is very exciting. So here we have mice that are on the space station for doing experiments, and we are looking for a new way to be able to feed the mice instead of the old-fashioned way that we have in the past, and that we are currently doing. So right now we have on the order of about 20 mice on orbit in 2 different boxes. Each box holds 10, and they are separated out so that there are 5 mice on either side of this particular container. And again, if you notice at the bottom, there's another suggestion that there's more information on another in another PowerPoint kind of presentation, and it will give you lots of details. It will include some drawings of what kind of parts that we're going to be looking at as well. But the difficulty is that right now on the station, we have kind of a block of food that gets that the mice are able to access at any time and be able to chew up that food and eat as much as they like. But being mice, they also like to just chew. And so now they chew up a great big block of food without necessarily eating it. That makes a big mess, as well as it wears down all their food. And because it's a specialty product, the way it's been formed, it costs NASA quite a bit of money. And so it would be nice if we could make some kind of a dispenser that would dispense the same type of food as what they use here on the ground. And if you'll look over to the right there, you'll see that there are these pellets, and those are about maybe 1 inch to 1.5 inches long, and they're kind of oval shaped, not quite oval, but these are the standard pellets that would be something much cheaper and easier to put into a dispenser. And exactly what kind of dispenser we can make that will work in 0 gravity is going to be up for you to work on. And I've given you a couple of suggestions. So here you see some Pez dispensers. Imagine if we could put these into some kind of a dispenser like that so that mice could get it 1 piece at a time. And you can also imagine that if a mouse is floating around and there's a big block of food, that big block of food might get soiled on just because, mice are pooping and peeing all the time. So if we can minimize that kind of damage to the food, then maybe we can cut down on how much food is thrown away, as well as make it a little bit cleaner for those mice. Okay, this is not an easy one. The coming up with a good way to dispense in 0 gravity is actually fairly difficult, which is why we're asking you to try it out. One way to do it is to just kind of put it in a location and make it so that the mice can get to it through some kind of a cage or something like that, which is possible. But then chances are the mice would be able to get it all dirty, and we'd like to avoid that if possible. This is also kind of exciting because we would be making a big improvement on experiments that are being done right now. So this could have some big advantages for our mice, and even for the people that are doing all these experiments, and especially for the crew members who would not have to be handling the mice as much. And so that would also be a big advantage. Last year, we started off with a Hunch washing machine, which contains 7 different projects. This year, I'd like to continue that. This is a very complex project. I had some very good projects come through last year I'm very excited about. This year, I know that there are some students that were wanting to continue working on their project and bringing that a little bit further into the development, and I would encourage that as well. I know that I had some students that had done some of the control system and doing some programming. They were working with a Raspberry Pi and I believe also some Arduino to be able to control some of the different devices that would be used in this. All of these, I think, are terrific to continue on. If you had good ideas from last year, I encourage you to continue with that. If you are interested in starting off on this, I think there's still some good room for people to come in with their ideas. Last year, I had a lot of students that started off with trying to come up with their own method for working a washing machine. Some of them were very interesting and exciting. Some of them were kind of going in a different direction than I was hoping. I'd really like to encourage you to stay with thinking about this washing machine kind of like a printer, so that you would take the shirt and kind of feed it into the machine, and it would go through several rollers and a couple of different cycles, and then get spit out, kind of like you might a piece of paper that goes through the printer and comes out with it all cleaned up. So part of the reason for that is that when we use bags in space, we have to worry about how much they're going to get damaged going through different processes and whether they would leak and then cause other problems. There might be other options, but you should send me some emails and talk with me about that before you start going down a long path. I'm trying to use rollers so that we have less problems with the clothing getting all over the place. Bags are difficult because you have to stick a shirt or clothing in there, and then to be able to transfer it to the next thing, you have to take it out, and we're trying to have it as automated as possible so that the astronauts can put the shirt in or the clothing in and then walk away or float away and come back several minutes later. So we're really trying to get as much automation into this system as we can so that crew don't have to spend a lot of time washing clothing. Okay. Let's see. This is a brand new one. Several years ago, I was talking with one of the astronauts who was telling me how he was going to take a paper airplane, kind of like what you see in the lower right-hand corner, and he was going to release 30 of these things outside of the space station and let them fall to Earth and hope that people would pick them up. Now that sounds amazingly impossible because everything seems to burn up when it comes through the atmosphere. However, we have some good evidence that things can make it through the atmosphere if they are very small, if their mass to volume or surface area is right. You can imagine that they might be able to get through just because a little burst of air can slow down or speed up a paper airplane very quickly. And the hope is that we might be able to develop some type of a satellite that could be released in space, slow down by way of just the friction of air, and then be able to land on the ground somewhere and be picked up. And so what I'm looking for are people that might be able to try this out, because you'll see if you go to the attached page here, or to the adjacent page, that there are things that have come down through space, and we've picked them up in the atmosphere. That some other people have been trying to do some similar things, and even NASA has made attempts at this by increasing the size of the vehicles that are coming down through the atmosphere. I'm not exactly sure how this is all going to work out. Be watching this page, because through the year I may be making some changes to make it a little bit more applicable or helpful for you. I know that I've got to work. Oh, I see I've got an antenna size there. I might need to be adjusting that, but don't be afraid to send me questions, and we'll see if we can work out what else we can do with this. This is not a one-time, a one-year project. This is probably going to take a year or two for us to be able to fully develop it. Least of all, trying to find somebody that will help us with a launch. But this is also something that could be pretty exciting for NASA and other space programs. this one is also pretty exciting. When right now we're being asked to go to the moon, and so when Apollo went to the moon, one of the problems that astronauts had was the amount of dust that came back into the spacecraft on their clothing. And because of that, the dust on the moon is very abrasive because there's no water and there's no windstorms. These dust particles are actually tiny pieces of glass. They're very sharp. And so when the crew came back into their capsule, or came back into their lander, they all of that dust that was on their clothing would stick to the walls, partly because of static electricity, but also because there's less gravity. These particles would float up in the air a little bit more. And you can imagine if dust particles are in the air, that you might be breathing them. They might get in your eyes, and especially if they're sharp, that could be very dangerous. So the next time we go to the moon, we'd like to come up with some good ways to mitigate some of that dust. We are looking for ways to be able to, first of all, we've got to get that dust off as much as we can, so that the only dust that we're bringing back is going to be in our sample bags, right? Now, you might find out that there are other options, and I'm sure that there might be some other options. However, a brush is going to be a simple device that really needs to get made. Now, one of the difficulties is you're in a big puffy spacesuit. How do I brush off all of this dust easily? I am going to have a partner that I'm going to be working with, and so maybe some of these brushes that you come up with might have some longer handles, might have some angles on them so that you can reach back behind and around, but also be shared by, I can brush me off and maybe I can help you get brushed off. The other thing is the materials. Because we're going to the moon, I can't use plastic brushes. Some of these are going to be, they might get melted by the temperatures, or they might get brittle because of the temperatures, because we can go up to 250 degrees Fahrenheit and all the way down to negative 250 degrees Fahrenheit. Some plastics will just shatter at those lower temperatures, and some will melt at those higher temperatures. So we need you to think about some of these different options, and you'll see that there's a link there, it's in blue, that takes you to a description of what's going on from what had happened in the Apollo missions. This is also related to lunar dust. So some of the good ideas that I've heard from NASA at times was that if we were going to try to prevent some of this dust from getting into our spacecraft, a very simple thing is to make lay down a tarp right next to the lander ladder, and so as you come back in, getting ready to go back onto the lander, you'd be able to have a place where you're not going to pick up more dust. So it'd work like a front porch, and all you got to do is, that's a good place to dust off without picking up more dust. However, anytime you've got a tarp laying on the ground, you may end up tripping on that tarp. And how do you hold that tarp down so that astronauts don't trip and damage their spacesuits, which could result in them, having a leak in their spacesuit, which would be very dangerous. So these are some of the things. We're looking for some way to be able to hold down that tarp, and potentially we might be able to use whatever kind of mechanism you use to hold down the tarp. There might be another use for it as well. If I can put a good sized stake in the ground and it's going to hold other things, it might also be valuable to have something that sticks up out of that. Excuse me. So we're looking for a way to put these stakes, whether it's a hammer in, or maybe a screw it in with your hands, or maybe use an electric drill to be able to put it into the soil. These are some of the ways that we might be able to put it in. There might be like a hand crank way to put it in. Um, Part of the difficulty is that you're in your spacesuit, and to kneel down with that backpack on, and every time you kneel down in a spacesuit, all of the air that was in the legs of your spacesuit gets pushed up into the chest and the hands of your spacesuit, so it makes it a little bit harder to be able to work with your hands. So there's a lot of difficulties associated with being in a spacesuit and being on the moon, that we're going to have to work through when we're trying to assemble whatever devices we want to help us out on the moon. And this is one of those things that could be very helpful if it's easy to work with. I don't have to kneel down. Maybe I can install it from a standing position. Lots of options I'd like you to look at. Okay. So in the past, on the lunar, on the Apollo missions, we had some sample tongs, kind of like what you see on the right-hand side there, and it's kind of very similar to like what you might pick up trash with. In this particular case, the tongs. Let's see. So you grab the rock with this side, of course, and then as you squeeze this, it opens up the tongs and be able to grab the rock. However, these were able to pick up things about the size of a golf ball on the moon. We would like to see if we can make another set of tongs that can handle something a little bit bigger. And at the bottom of this page, you can see that I've got some other tongs that might be helpful. And part of the question is, how do you want to grab the rock? How do you want your hand to work with these tongs? Is there one method that's easier than another? And you should do some of your testing with kind of bulky, heavy gloves on and see how that affects your ability to grab and hold on to that. If it folds up, that might be helpful, just because we don't want to have. I don't want my astronauts to have to carry lots of tools down from inside the lander. They need to be able to have these on the outside of the lander, so that when they walk down the ladder, they can get their tools from there. And making them fold up and making them compact is also very important. So doing some testing will be important. It'll also be valuable, not only of how you pick things up, but how do they drop, right? So if I grab a rock and I want to put it into a sample bag, then I need to make sure that it will, I can put it into a sample bag very easily. I might have my partner holding the sample bag, and having them holding that bag might affect some of the characteristics that you put onto your tongs. Okay. This one's very exciting for me. I think everybody would be very proud to be able to say that they helped design the flagpole that was used on the moon. The first flagpoles that were set on the moon were, let's see, out of the 6 that landed on the moon, I believe only 3 of them stayed up after the astronauts took off. You can imagine that that when the ascent module, when the lunar module takes off from the moon, there's a whole bunch of wind coming from that engine, and that's pretty much what knocked over many of these flagpoles. And the only answer that they really came up with was, hey, you need to move the flag a little bit further away from the launch site. I think that's a good solution, but I think that we might be able to help out with a couple of other options. Similar to those tarp stakes, you might be able to work with that team, and you might even come up with some ideas together that would help out with how to hold it in place. One of the other thoughts I had was, if you've got your flagpole, and maybe if there was some kind of a bag at the very bottom of it, you might be able to kick some dirt into that bag, and that might help hold that flagpole into place. Do you want to screw that in? The original ones, the original Apollo flags, I believe they were a couple of pieces. So they would take one piece, kind of pound it into the ground, and then they would take the top piece and slide it into it, and then the flag portion would kind of flip out. And I believe there was a telescoping portion of that. And if you read on that link that's on the page there, I think they'll help you understand that a little bit better as well. So this is I think that'd be pretty exciting. I'm hoping to have some of our sewing team be able to make some of the flags that would go onto your flag poles. So I think that'd be pretty exciting. Now, when the astronauts land on the moon, the first astronauts, Buzz and Neil Armstrong, they stayed on the moon just for one sleep cycle, just for one night. And so some of the later missions, they stayed as long as 3 days, I believe. And so they had to sleep on the moon's surface inside their lunar lander, and it was not very comfortable. Down at the bottom, you see that I suggest you watch Apollo 12 from Earth to the Moon. There was a HBO series on that, and on Apollo 12, I remember them having some conversations about how they were not very comfortable inside their lunar lander, trying to sleep for that night that they were on. So here we're looking for some way to be able to make some kind of a hammock or a sleep rack or something that would allow the crew to be able to rest overnight and be able to enjoy that. And some of the difficulties, as you can imagine, is at least for me, I cannot sleep in a hammock because I can't really roll over. Now, some people might feel differently about that, but part of the deal is we need to make this a good option for every crew member if possible. And it doesn't mean it has to be, a great big bed, but it needs to be a fairly flat space that doesn't sag a lot so that the crew member can be comfortable. And I'm not exactly sure what that means because we're talking about 1/6 the gravity of Earth. And so this might be very different from what we're used to. So you'll have to think a little bit further than just making a twin-size bed or something like that. Another difficulty is that it has to be super lightweight. I was talking with some engineering people the other day, and they were talking about arguing about ounces. That they're very concerned about how much weight this is going to be. And so the lighter weight it is, and the more compact you can make it, the more likely that you're going to have a good idea. Okay? Wow. So this one's kind of difficult, but I think that a lot of students can handle this. The idea is that on the first couple of missions, the astronauts did not have a lunar rover to drive around. That was only for the last 3 Apollo missions that they had a lunar rover. So on the very first one, they didn't have anything for toting around tools or anything. They walked around and they picked up things and they put it into a basket or a box or something like that, and then brought it back home. For the second and third ones, they had a tool carrier, so kind of like a wheelbarrow or a wagon to kind of push or pull around, and you can see it a picture of it there for Apollo 14. This was, I think that they would pull that rather than push it, but you can see that there's tools in there. There are sample bags so that the crew didn't have to carry each and every rock. They could put it inside their wagon or wheelbarrow and be able to take it back. Well, they're going to need another one, right? And they were not very happy with that one. And you can read up on it. I think you can find some information on what they thought about it, just doing a Google search for this. And so I've made a suggestion here of, I went over to Academy and just picked up one of these collapsible wagons, and I'm suggesting that you guys might pick up something like this. It doesn't have to be the exact same one, but the idea is that I don't need you to design the whole wagon. I'm actually asking you to design the most difficult part, which is the wheels. You can imagine that they're going to be pulling tools and samples, rocks, around with them as they find what they want. And these have to, they have to pull it through this very soft, dry sand, which could be very difficult. And again, some of the difficulties with this is that we're on the moon without air, and we are with we have temperature swings between 250 degrees Fahrenheit in the sun and negative 250 degrees in the shade. So I might have one of these wheels in direct sunlight, and it starts to get hot and bubbly or whatever, and then the other one could be cracking because it's freezing cold. And so your challenge is to be able to come up with some kind of a wheel that that we could use on the moon, and there are examples of this on the web that you can find. But which ones would be which ones would be a good idea for this lunar wagon? I know that Johnson Space Center is working on this, and I know that JPL has a variety of different wheels, and I try to give samples of those things. But this is a unique opportunity to develop a new kind of tire that will be good for that environment. And again, on the bottom of this page, I refer you to making sure that you go to our supporting documents page so that you can get some more information on this. Okay. Aha, and that's the end there. I think that we'll probably do another video for each one of the extension pages for the supporting documents, and that way we'll be able to point you in the right direction. Allie, would you like to talk about our web page?
Sure thing. Let me get to where I can.
Oh, I got to stop sharing, don't I?
Yeah, you need to stop sharing, and then I will start sharing on my end.
There you go.
Okay, give me just a second. Let me get our website up. Okay.
Allie's been working and making all kinds of updates to our webpage for the year. I think that we've got a lot of new things to share with you, including the design to flight. We'll be adding some more web pages as we go.
Okay. All right. So just to kind of go through a little bit on this website, if you want to share this with students so that they can actually have an opportunity to see, you know, what we're doing on this end, that might be helpful for them as well. So, okay, we have at the home page, we have kickoff videos like we've had in the past, and so they can go through all of these videos. We have, of course, helpful links page, and then we have an expectations page. This expectations page is going to give you a document on research on microgravity. So if the students want to start out their projects by doing a little research, we find that that can be very helpful for them as they're developing their projects. We have on here like web conference expectations that we feel are good to have. Preliminary design review expectations, critical design review expectations, and then for the Houston final review. So all of our design reviews, as we've stated on the website, are going to be taking place depending upon the center that they're going to be located at. They will be taking place basically November, December. And then our critical design reviews will be in February to early March is what we're expecting. Now, some of the mentors may have it in a little bit different area. We go to, I'm sorry, go back to here. So every single person that's working design and prototype, the teachers and the students, need to go over here to the talent authorization forms and click on that, and it goes to an online document. And this is also going to populate our database. And so our database is where we get all of the information that we need for the final certificates for the end of the year. So we need students to go do that, and teachers. And then if you go to the design projects, you're going to see our projects here that Glenn was just talking about. And then you'll also see the design and prototype student template. And this is just to give them something to go by. They don't have to use this. It's just something that we put out there as an example that might help them through their project. Also, on some of our pages, we'll have links to the supporting documents, which I'm about to show you as well. Okay, so if you go to project information and supporting documents, we have on here some new documents, and we'll be adding to this. So the website, consider it kind of a living, breathing website. It's going to be updated regularly. Things may change on it. So that's our new documents that Glenn was talking about, having like a little video for each of those. And then we have the documents from last year, which you can see, because sometimes those documents from previous years might be helpful. Then we have general information and drawing files, and those can also be very, very helpful. Google Map of the ISS. If you have students that haven't seen this yet, it's a very neat tool. So you can actually take it and run through the International Space Station, look at all the different areas. You could even play a Where's Waldo game for Hunch, because we have over 400 items on the space station of student-built items that have Hunch stickers on them. So that's also a good thing to go to. Let me go up. Okay. We also have helpful links on here. And then our timeline, we have the different areas, and hopefully these timelines will be updated soon so that all of the students can have the good information. Current and former projects, these are just different projects that have either flown or are getting ready to fly, and so the students and teachers can look through this and see what is there. It's a neat area that Glenn has been adding a lot of information to. If you go to the More side, you'll see winners and contenders for 2018 and winners and contenders for 2019. And we consider winners those that are coming to Houston, that have been invited to Houston, and the contenders are the ones that were really good projects that we then had to down select from to choose the winners. So that's pretty much a look at our website, and I hope that this will help everybody through any kind of issues that they might have, and make sure that they're looking through all of the aspects of the website, because it can help them in their project design. Are there any questions from anybody that's online?
Nothing for me.
Okay. How about you, Yolanda? Did you have anything? All right, well, I think that we're good then. And I am going to stop the recording here, and then we can be done with this video.
All right.